This tutorial will show how to model, analyze, and design a concrete slab in SAFE. The model will be started from scratch without using any templates and will consist of an arbitrary grid on which beams, walls, drop panels, columns, slabs, and openings will be drawn. First, verify that the default or database units are set to pound-feet. Next, go to the File, New Model command. This will open the grid definition form. Here we will specify the grids needed to allow us to quickly generate our model. We will have 6 grids in the X direction and 9 in the Y, with a starting spacing of 20 and 18 feet respectively. Click on the Edit Grid button to modify the spacing of the individual grids. We start with the X grid, and note that you may edit using either the ordinates as we are doing here, or by spacing. Now switch to the Y grid and edit as needed. It is important to define a grid that captures the major geometric features of your slab, as this will expedite the modeling procedure. The grid is now complete. Next, we will define the properties and supports. Start with the slab properties. We will modify the default property, slab 1, to be our primary slab. Make sure that slab is selected as the type and set the thickness to 10 inches. Note that when we explicitly state the units, the program automatically converts them to our database units, in this case inches to feet. Next, we will add a new property, this time for the drop panels. It is important to select the type as drop so that the program will know to use the drop panel properties at locations where both slabs and drops are specified. The thickness should be 16 inches. Add one more property type for the columns. These objects will be used primarily for geometric definition and should be identified with the column type. We use an arbitrary thickness of 5 times the slab thickness so that these objects will be at least a magnitude of 2 times stiffer than the slab. Mark the No Design box, as the column should not be designed using slab techniques. Next, go to the Define Beam Properties command. We will have a beam that is 12 inch by 24 inch around the perimeter. For the column support, the spring stiffness will be based on a rectangular column of 18 inches by 18 inches and 12 feet tall. Wall supports are based on a 1 foot thick wall 12 feet tall. Material properties are all based on a compressive strength of 4,000 psi concrete. For this model, we will have 2 static load cases. A dead load case with a self-weight multiplier of 1 and a long-term deflection multiplier of 3. We will also have a live load case with no self-weight multiplier and a long-term deflection multiplier of 1. We are now ready to start drawing the slab. Before we do, we will set the number of windows equal to 1 to give us a slightly larger drawing area. Also make sure that the Snap to Grid is on, and then click on the Draw Area button. In the Properties of Object box, make sure that the property is set to Slab 1. To draw the slab, click at grid A9, and going clockwise, click at F9, F1, D1, D4, and A4. Hit the Escape key or Select button to leave the draw mode. Note that the entire slab was created with a single area object. The program will automatically mesh the object internally to create the finite elements needed for the analysis and design. However, we do need to move the slab edges. As drawn, the slab edges line up with the grid lines, but to accommodate the width of the columns, which are 18 inches wide, we will need to typically move the slab edges out 9 inches. We will move the slab edges by moving the corner point objects. Start by right-clicking on the point object located at grid intersection A9. We move the coordinates up and out 9 inches or 3/4 of a foot. When we zoom in, note how the slab object moves with the corner point object. We repeat this process at each of the other corner points. Next, select the Draw Point Objects button and make sure that the Column Support property is active in the Properties of Object form. Click at each grid intersection that has a column support to draw a point object that has assigned spring stiffness equal to our column. Hit the Escape key or Select button to leave the draw mode. Next, click on the Draw Line Objects button, and from the Properties of Object form, set the line type to All. Draw the walls as single lines, clicking at the starting and ending points, and right-clicking when you want to start a line at a different location. Hit the Escape key or Select button to leave the draw mode. All of the supports are now assigned. Now we will add the drop panels. Click on the Draw Rectangular Area button, and in the Properties of Object form, set the property list to drop, and the X and Y dimensions edit box to 6 feet each. Use a single click, do not drag, at each grid intersection to position a 6 foot by 6 foot drop panel. Hit the Escape key to leave the draw mode. For the drop panels located on the perimeter edges, hold the Control key down while right-clicking on these panels, and select the area object representing the drop. Edit their size using the slab information form so that they do not extend beyond the slab edge. Next, we will add in the column objects using the same technique. Click on the Draw Rectangular Area button and set the property to column and the X and Y dimensions edit box to 18 inches each. Again, use a single click at each grid intersection where a column exists. As noted earlier, these columns are primarily to ensure that the other elements have the proper geometry. Hit the Escape key to leave the draw mode. Now that the columns have been defined, add the perimeter beams by clicking on the Draw Line Object button and selecting Beam from the Type of Line list. You may draw all of the beams along each edge as single objects. Hit the Escape key to leave the draw mode. To add an opening, click on the Draw Rectangular Area button and select Opening in the Properties Edit box. Click on C8 and drag to D6. Hit the Escape key to go into the Select mode. Next, we will assign the loads. Start by selecting the primary slab object. You should see one area selected in the lower left-hand corner. Go to the Assign, Surface Loads, and select the dead load case name and enter 30 in the Loads Edit box. This will be 30 pounds per square foot in the down direction. Click on the Previous Selection button and again go to the Assign, Surface Loads. But this time select the live load case and enter 50 pounds per square foot into the Loads Edit box. The model is now ready for analysis, but before we start the analysis, we will review the finite element mesh generated by the program. This is shown by going to the Set Object Options and Show Mesh command. Once we are sure that the mesh is appropriate, we may start the analysis by clicking on the Run Analysis button. Once the analysis is complete, the deformed shape for the dead load case appears. At this time, we will add another window with a 3D view on the right side. Here, we will display the deformed shape for the live load case. Make the left window active and go to the Display menu and ask to display the moments. To design the slabs and beams, go to the Design Start Design command. The required reinforcement in the X-strip direction appears. Moving the cursor over the model displays specific top and bottom reinforcing values in the lower left corner of the screen. We may also view the reinforcement in the Y direction strips. Required beam reinforcing may also be displayed, with values again displayed in the lower left corner of the screen. This concludes this tutorial.